Another similar problem, not similar, but a difficult problem, difficult to understand, that how the constraints will be formed. After that, solving will be easy. So what we want is we have to solve this graphically. They have said express LPP and then solve graphically. Final answer tak jana hai. X and Y ka value we have to find out. But kya karna hai? What we have to do in this sum is, let us just go through quickly the question. It's not a typical question where the data is available directly and you can form the constraints easily. It's like the previous sum only. Thoda difficult hai to extract the data. Okay, so motorcyclist rides at 30 kilometers per hour, has to spend rupees 3 per kilometer on petrol. If he rides at a faster speed, that is 50 kilometers per hour, तो पर किलोमीटर कॉस्ट भी बढ़ जाता है एंड इट बिकम्स 5 rupees. He has maximum of 150 rupees which he can spend on petrol. उससे ज़्यादा वो spend नहीं कर सकता है पेट्रोल पे, and he wishes to travel maximum distance in 1 hour. Within an hour. It's not in 1 hour, sorry. It's within an hour. So it can be in less than 1 hour time also. But 1 hour को 1 hour के ऊपर नहीं आ सकता. It has to be within those 60 minutes. If it is traveling maximum distance in 45 minutes also, by balancing properly, he can do that. Balancing the speeds properly. And 150 rupees खत्म हो जाएगा. 45 minutes पे भी खत्म हो सकता है. 50 minutes पे भी खत्म हो सकता है. There are two constraints. It is time constraint and money constraint. If he is riding slowly at 30 kilometers per hour and is spending 3 rupees per kilometer on petrol, right? If he is riding slowly, पैसा बच जाएगा, time खत्म हो जाएगा. If he is riding faster at 50 kilometers per hour, पेट्रोल का पैसा खत्म हो जाएगा, time बच जाएगा. Are you understanding? If he is riding slowly, पेट्रोल का पैसा शायद बच जाए लेकिन टाइम खत्म हो जाएगा. इफ इज राइडिंग फास्टर, पेट्रोल का पैसा खत्म हो जाए, टाइम बच जाएगा. राइट, सो वैसा है. सो इट वी हैव टू बैलेंस आउट प्रॉपरली so that we can achieve our goal of maximum distance within that 1 hour, within that amount of rupees 150. Okay, so what we have to maximize? We have to maximize distance. So identifying decision making variable here is a challenge, and that hint lies with this. Objective is to maximize the distance. So let distance covered at 30 kilometers per hour be x kilometers and distance covered at 50 kilometers per hour be y kilometers. We have to maximize total distance covered, that is x plus y. So we have to maximize total distance covered z, which is x plus y. Okay, now per kilometer, if he is riding at 30 kilometers per hour, per kilometer he has to spend rupees 3, right? So amount spent on petrol while traveling at while traveling at 30 kilometers per hour is equal to 3x rupees. Rupees 3x. Similarly, it will be at 50 kilometers per hour. How much it will be spent? Rupees 5y. Okay, here it is rupees 3x, there it is rupees 5y, because it is 3 per kilometer at 30 and it is going to be 5 per kilometer at 50. So at 50 kilometers per hour, we're going to have 5y. So total amount spent on petrol is 3x, 3 rupees per kilometer when it is at 30. So x kilometers will require 3x rupees. 5 rupees per kilometer when he is riding at 50 kilometers per hour. So y kilometers traveled at 50 kilometers per hour will need 5y rupees. So total amount will be 3x plus 5y. But that cannot exceed 150. That cannot exceed 150. Okay, that is the first constraint we have. Okay, that is the money constraint. Okay. The next constraint will be the time constraint. Time cannot exceed 1 hour. It has to be within 1 hour. Everything has to be completed within 1 hour, right? So time needed to travel x kilometers, it is going to be x upon 30 hours. Distance upon speed. I've used distance upon speed. Okay. Similarly, time to travel y kilometers is y upon 50 hours. X upon 30 plus y upon 50 cannot exceed 1 hour, right? That is the second constraint. Okay. So the total time spent in traveling has to be less than or equal to 1. So it has to be less than or equal to 1 hour. So that is the time constraint we have. So first constraint was very easy. Understanding it was very easy. Money constraint. 3x plus 5y less than or equal to 150. The second constraint is the time constraint. Within 1 hour you have to finish this. So what is the final problem now? Final problem looks like maximize z equal to x plus y, where x is the kilometers traveled at the speed of 30 kilometers per hour, y is the kilometers covered at the speed of 50 kilometers per hour, right? Subject to, there has to be constraints now. The constraints are subject to, the constraints are, the first constraint is the money constraint. The money constraint says that 3x plus 5y cannot exceed 150. The second constraint is x by 30 plus y by 50 cannot exceed 1. There are two more constraints which we are not writing here, which we are missing out, is non-negativity constraints. The distance covered cannot be negative. Feasible region cannot go outside the first quadrant. That is the final answer. Okay. After that, you have to solve it graphically and find the values of x and y. Right? You can plot the, इसमें आपको x by 50, y by 30 मिलेगा. 30 and 50, x intercept, y intercept. इसमें you will divide by 150 in the first inequation. You divide by 150, you get 50 and 30 as the first inequation. 50 and 30 will be the x and the y intercepts respectively. Here it will be 30 and 50. डायरेक्टली है वहाँ पे, कुछ करने की ज़रूरत नहीं है. and here this is it is first quadrant. You find out the point of intersection, find out the maximum value of x plus y. Okay, so I hope it is clear. It is important to understand this time constraint. Otherwise, money constraint is very easy. And identifying the decision making variables. The decision making variables are distance covered at the speed of 30 kilometers per hour and distance covered at the speed of 50 kilometers per hour. Okay, so these are the two problems which I felt from your exercise were little difficult to identify the decision making variables and to make the constraints out of it. So I did it for you. Remaining problems you have to do as homework.